Hello guys, welcome back to my YouTube channel. My name is Yasser Ahmed. So we are going to continue with our computer science tutorials, and if you check out the playlist, I've completed a video on binary, which is base 2, which is made up of zeros and ones, and I've done the first part of the hexadecimal videos. So hexadecimal is base 16. It's made up of 16 characters, including numeric values and letters as well. So what we're going to be doing in this video is we're going to be looking at converting hexadecimal to denary. And there's going to be two methods that I will be showing you, so you can choose which method is best for you. So this is the first method. So what we have is we have two hexadecimal values, so F and 9. Okay, so if you look at this table, the denary for F is equal to 15, and 9 is just going to be the same as 9. So if we come back to here, and remember, each hexadecimal value has 4 bits of binary. So F is going to be, the first part we need to do is we need to convert these into binary. Okay, so for each hexadecimal value, so F is going to be 8 plus 4 plus 2 plus 1. 9 is going to be 8 plus 1. And we don't need to add anything else. Let me just take out all of these highlighted. Okay. Once you've done that, then we can drop these values down into the 8-bit register. So exactly the same, 1, 1, 1, 1, 1, 1, and then take away from here. So 0 and 0, we're not adding these values. And so what we need to be doing is adding 128 plus 64 plus 32 plus 16 plus 8 and plus the 1. So I know the maximum in 8-bit register is 255, and we're not including 4 and 2, so the answer should be 249. Okay, so let me just put that into here. If you want to double check, we can use a calculator. So 128 plus 64 plus 32 plus 16 plus 8 plus 1, and we have 249. So that's the first method that we can use if you want to convert hexadecimal to denary. So first step was to convert each hexadecimal value into binary. And remember, each hexadecimal value has 4 binary bits. Then we put this into the 8-bit register, and then we get the answer. The second method, which we'll get to in a second, let's just complete this one here. It's the same steps, basically. So A is going to be 10. So you can check back to this table. So A is equal to 10. So 0 here, 2, and then 0. And I don't know what it is with these highlights. Let me just get rid of them. Okay, 7 is still the same. So 4, 2, 1. And then D is going to be 13, which we need to add up to. So that's why it's really important, guys. If you can, write down the conversions when you are answering these questions, so you have a reference point. So D is, let me double check, is 13. So 8 plus 4 is 12, plus 1 is 13. Then once you've done that, we can just put these values down to here. So this is a 12-bit register now. Let me just use my calculator really quickly. Whoops. What I'm going to do, just to help me out a little bit, just zoom out a little bit. Get the calculator back up. Putting that this side here. So 2048 plus 512 plus 64 plus 32 plus 16 plus 8 plus 4 plus 1. And the answer is 2,685. Okay, so let's zoom back in again. So guys, obviously in the exam, if you are doing the exam, sometimes you don't get access to a calculator, so you'd have to work out these in your head. But that's basically what you need to do. So convert each hexadecimal value into binary, and then convert all of that into the 12-bit register, and then add up. When you see a 1, you just add up this number, and then next time you see a 1, you add up the next number, and so on. So you can see these are increasing by the power of 2 every time, since binary is base 2 and only has 2 inputs, or 2 values, zeros and ones. Okay, so that was the first method. Let me show you the second method. And remember, we talked about the power of 16. Each unit increases by the power of 16. So you can see this is what we have here. So we have a table, 1 and then 16. And then if we had an extra hexadecimal value, it'd be 256 and so on. So we're going to convert hexadecimal to denary using the second method. The first thing that we need to do is to convert this into denary. Okay, so F is 15. Okay, B is 11. And then we need to multiply this by this. Okay, so 15 times 1 is still 15. And 16 times 11, I think 176, but let me just do it on a calculator. 16 times 11. Yes, I should trust my math skills. Okay, and then what we can do is we can add up these numbers together. So 176 plus 15 is equals to 191. Okay, and let's do this one here. So you can see we have these values going up by the power of 16. Okay, and the first thing that we need to do is convert these values here. So 2 is going to be the same. 3 is going to be the same. D is going to be 13. Okay, and then we need to multiply. So 3 times 1 is still 3. We just make these numbers a bit bigger. 13 times 16. So let me just do that by calculator. 208. 2 times 256. 512. And then we can add up all of these numbers together. So 512 plus 208 plus 3, 723. So let me just copy and paste this down here. So that's the conversion for that. 723. And let me double check that, guys. What I'm going to do is is that the end of that? Yeah. 2D3. So let's use this method here. And let's see if we get the same answer. So 2D and 3. So 0, 0, 1 here, and 0. And D is equal to 13. So 8 plus 4 plus the 1, and then 3. So 0, 0, 1, 1. And then what we can do is we can just copy these down here. Okay, let's do the calculation now. So so we got 512. Okay. Plus 128 plus 64 plus 16 plus 2 plus 1, and we got 723. We write it down, and we got exactly the same here, 723. So guys, it's completely up to you which method you want to choose. You can see both gets the same answer, so it's up to you whatever works best for you. I did use this initially, but I think this is quite an easier method to remember. Right, if you join us in the next video, guys, what we're going to be doing is looking at how we convert a denary value into hexadecimal. So that will be the next video. Okay, so please drop your comments below, like and share, and please subscribe to the channel as well. Thank you again. Bye-bye.